Hi, everyone, and welcome to our webinar, New Way to Reduce Database Cost with ScyllaDB, especially reduce cost in the cloud. A few housekeeping rules before we get started. So feel free to ask a question in the chat throughout this session. And we will try to answer as best as we can. Also, this webinar is recorded, and we will share the slide and the recording right after. But do stick to the end. It's getting more and more interested as we move forward. So I'm actually on the bottom here, but let me quickly introduce myself. Zach Leviatan, VP Product at ScyllaDB. I'm long time in ScyllaDB, 12 years by now. Before that, I used to work in the telecom domain. And before that, I don't remember anymore. And I will let Michael introduce himself.
Yes, hey Tar. So I'm Michael Hollander, Director of Product at ScyllaDB. My main focus is on Scylla Cloud. In the past, I led product at multiple DevTools companies, both smaller companies, bigger companies, and I was a full stack developer for around 10 years. Yeah.
Thanks, Michael. So what we're going to do in the next 45 minutes or so, I'm going to introduce ScyllaDB for those of you who are not familiar with it, the company, the product. Then I'm going to talk about how ScyllaDB database, or the core as we call it, help you to reduce cost in the cloud. And then I'm going to switch how to ScyllaDB Cloud help you to reduce cost. And as you will see, it's not exactly the same. Scylla Cloud, spoiler alert, Scylla Cloud is a managed service that runs ScyllaDB, but it has a lot of other functionality. In particular, I will switch over to Michael in this part to explain you flex credit capability that we are already in Scylla Cloud that, again, help to reduce cost. So without further ado, let's get started. What is ScyllaDB? ScyllaDB is a NoSQL database created, as I mentioned, about 12 years ago. The two founders, Avi and Dor, are coming from Linux kernel heritage. Avi developed the KVM, the popular hypervisor that some of you might be aware of. ScyllaDB was designed from scratch with performance in mind. And when I say performance have different meanings to different people. Usually at Scylla, we look at two parameters when we talk about performance. The first is throughput, meaning how many requests per second, read requests, write requests, the server can handle per second. And we're talking about millions in the case of Scylla. A second parameter, which is also very important, but not for this webinar, is latency. In particular, tail latency or P99 latency. We actually have a full conference called P99 focused around that. So if you're interested in operational aspect of low latency system, you're more than welcome to check it out. Again, we have full webinars on that, even a full conference, not the focus of this conference. ScyllaDB come in two variants, ScyllaDB Cloud and ScyllaDB Core, or ScyllaDB Enterprise. The latter, you can download, deploy it yourself, either on the cloud or on-prem. The former Scylla Cloud is the main way people use Scylla today. It's fully managed solution. You can run it either on Scylla account or even in your own account. And as I mentioned, this is the most popular way people consume Scylla these days. ScyllaDB is compatible with two other popular NoSQL databases. The first is Apache Cassandra, and the second is AWS DynamoDB. And when I say compatible, I mean compatible in the protocol level. If you have an application running with either of these databases, you just need to change the IP, and it will seamlessly work with ScyllaDB Cloud. We do have our own fork for some of the driver to get even better performance, but it's not a must. So as I mentioned, the focus is on throughput, latency, and TCO saving, and high availability. What is high availability? Again, not the focus of this webinar, but just to like give you introduction to what ScyllaDB is, if you're not familiar. Like DynamoDB and Apache Cassandra that I mentioned earlier, ScyllaDB is highly available in a sense that it can be deployed on multiple regions. Each region, it's usually deployed on multiple zones, and each zone can have multiple nodes, so you have layers and layers of high availability. The database is eventually consistent. That means that you can, per session, when you send either read request or write request to the database, you can set which consistency level you want for this request. Usually the way that people use it, especially on multi-region deployment, is what we call local quorum. So for example, I don't know if you can see the pointer, but for example, an application deploy in Europe, work locally with a Europe data center, and every update request use local quorum. So the database will respond back to the application with an ACK and once you get a local quorum. Offline, it will also send the update to all data centers. In Scylla, all the nodes are symmetric and all regions are updated in real time, but the application doesn't have to wait for the latency between regions. Typically, the latency inside the region in AWS or GCP, etc., or Azure, it's below 1 millisecond. Latency between region can be over 100 milliseconds. So it's a huge difference. And usually, users don't want to pay this extra latency for consistency. So the trade-off between consistency and latency, they prefer to have the consistency full or strong consistency on the data center and eventual consistency across data centers. Some of our customers, so you will see some common name here. I think the common between all of the Scylla users that are looking for a high available solution with big data and high performance. So let's jump to how to Scylla help you reduce cost on the cloud. So the main factor reducing cost, as I mentioned earlier, is high throughput. So it's a very simple math to move from high throughput to lower cost. Why is that? Imagine that each node can support 10 times the throughput compared to other databases. And that means that you need less or 10 times less number of nodes in each region. Sometimes it's not quite right because you still need the high availability, etc. But you can see the math is very clear. So the higher the number of requests per second the database can support, and the higher volume of storage each node can support, the less number of nodes you need, and the less money you pay the cloud vendor. And I'm sure every one of us want to do that. In addition to that, Scylla have a unique shard per core architecture that I will touch in a few minutes that help you use in a very efficient way a higher level machine, meaning more core in the machine. On all cloud vendors these days, you can easily get a 96, even more than 100 core per machine. And in Scylla, the cluster or the performance per node actually scale linear with the number of core. The more core you have, the higher throughput you have in a linear way. This allows you to reduce the number of machines. This by itself doesn't necessarily mean you save cost, because the bigger the machine, of course, it costs more, but it do allow you to make the administration easier. It's easier to manage a fleet of 6 nodes compared to a fleet of 100 smaller nodes, even if the cost is the same in this case. So I already mentioned that Scylla can support high volume of storage per node, up to 60 terabyte. It can support big machine or small machine, and the cluster can grow from 3 on one region to 20 nodes per region or even more than that. Usually you don't need much more than that because, as I mentioned, each node is very strong. How do we get this high throughput and low latency? So this is all based on 10 years of work, but we did make a few crucial decisions when we started Scylla, and I'm going to cover a few of this design decision right now. But again, it's not just there is no silver bullet for performance, and performance is something that we continue invest in throughout these 10 years, and very likely will continue to invest in it. So the first decision was to use C++ instead of Java. Not to get religious about it, I know people have very strong feeling toward programming languages for some reason, but Java didn't allow or does not allow today as well to have full control of the memory and storage that we wanted to use. By the way, when we started Scylla, Rust was not available yet. It is now. In Scylla, everything is async. This means, and this is very much related to the next point of shard per core, when we benchmark other databases, when we started, we found out that a lot of the resource of the database, and this is, by the way, true for many other applications, is consumed by context switch. Each process have 1,000 or 10,000 threads running, competing with each other, synchronizing in memory segment, synchronizing on disk, and do context switches all the time. And this is very, very wasteful. And one of the main I would say the number one design decision of Scylla is actually running one thread per core or one shard per core. You can think about it as a mini database running per core. So if you have a 16-core machine, you have 16 small database, partition the data between the core. Each core or each shard, as we call it, is responsible for its own CPU. It's have its own CPU. It's have its own memory. It's have its data to the storage is completely unsync, although they do use the same storage. So there is zero synchronization between the thread. There is zero context switch. And if two shards need to communicate, sometimes they do, they will do it through message passing. I'm not going to step into all the benefit that we have from a unified cache. By the way, I'm pointing here to a good presentation by MD Pavlo about why you shouldn't use mmap for your cache. We don't, but if you want to learn more, I highly recommend this presentation. Like all other databases, huge part of what the database is doing is working with the storage. And with Scylla, we invested a lot of effort in optimizing our usage of the storage. So before Scylla start, or every time we have a new instance type on AWS, and latest example is the i7i and the i7IE, we do benchmark for this storage, not just to understand its performance, but also to understand what is the sweet spot of parallel writes and parallel reads for this NVMe. And this is very important because if you naively think you can increase concurrency and send more and more parallel requests to the storage and get better performance, clearly this is not true. At some point, what the SSD will do is just start accumulating all of your requests in an internal queue. You wouldn't get higher throughput, you would get higher latency, which you don't want. And worse than that, you have no control of how the SSD or the storage actually prioritize the request. So the way that we handle it in Scylla is actually send to the storage the minimal number of parallel requests to get the best performance, while keeping the queues, the storage queue internally in Scylla, and actually prioritizing them by the database preference. We also allow the user to control this, this priority with a feature we call workload prioritization, which, again, I don't have time to step into it now, but some companies like ShareChat are using it to control which kind of workload get more shares, as we call it in the database, and that's another way to reduce cost. Latest and greatest feature that we recently added to Scylla that I want to mention is tablets. What is tablets? If you are familiar with older version of Scylla or Apache Cassandra, you are probably familiar with vnodes. Vnode is a static way to partition the data across all the nodes. And when you add node, each node allocate a few partitions to, or range query, as we call it, to the new node. And this works fine, but the scaling is pretty static. The assumption in previous version of Scylla was that the cluster is pretty static. You have X number of nodes in the cluster. Yes, if you are exhausting the storage or the compute, you can add node, but typically you wouldn't add and remove node or scale out and scale in every day or every hour. With tablet, all of that change, everything become more dynamic. I hope you can see this quick animation. This is the actual monitoring system that we have. It's not an illustration, it's the actual monitoring of the system. It shows a cluster that grow, let me run it again, that grow from 3 nodes to 5 nodes. And what you see here, the tablets are starting to migrate from the old node to the new node until the cluster become balanced. A tablet is basically like a storage and compute unit inside a table. So we split each table to many tablets. And the nice thing about a tablet is previously when you added a new node, you still need to stream all the data to the new node, but the new node become functional only when it's take ownership of its entire range. So it's time take hours until a new node start to be effective. And of course, if you need to scale the cluster, you usually need to do it fast, and that would be super inefficient. With tablet and xCloud, that I'm going to talk about in a few minutes, scaling is much faster, and each node already become functional with tablet after the first tablet migration. So a much more efficient way to handle scaling. I'm not sure you can read this chart, so let me quickly explain. This is a similar scenario when you start with a 3-node cluster at 3.15, 3 other additional nodes are added to the cluster. So the clusters scale out from 3 node to 6 node. The capacity stays the same. So you can see that the average load or number of requests per second is actually going down because now you have more node. Very quickly, you can see that once I add the node, seconds after the node is added to the cluster, it's already starting to serve requests. Yes, it's take more time until the cluster is stabilized. The tablet are streaming to the new node, and all the nodes serving the same number of requests, which you probably want. At some point, we started to scale in again, decommission 3 nodes, and as you can see, the cluster stabilized again. Everything's happened very fast. If you're familiar with other database or older version of Scylla, scaling could have taken hours. Now with tablet, it's taking minutes. And this brings me to the next topic with called xCloud. So on a very high level, xCloud is a mechanism to take advantage of tablet in the cloud. So Scylla Cloud already exists for a few years, and you already can use API or UI to scale the cluster out, to scale the cluster in. Everything is self-serve and automatic. But as I mentioned, it takes some time. With xCloud, we speed up or reduce the time of scaling both out and in significantly, and that's actually allow you to save money. How? With 2 factors. First, the fast scaling, and second, mixed size cluster. I didn't mention it earlier, but with previous version of Scylla, most deployment used 1 instance size across all clusters. So you will have, for example, I4I extra large, you will use only this instance size across all nodes. You can add node and remove node, but all the nodes have the same size. This works fine, but in many cases it's wasteful. Why is it wasteful? Let me quickly demonstrate it. So this is an example of quite a large cluster. By the way, this view is per zone. Think about, in practice, we'll usually have 3 zones. So you can multiply everything here by 3. So imagine that you have a cluster with I4I 16 hectolage, quite a beefy node with 15 terabyte. After some time, the storage is exhausted and you need to outscale the cluster. With a standard Scylla cloud cluster, you only could have add another node of the same type. So you add another I4I 16 hectolage and then another one. Again, this works fine, but it's very wasteful because there is a long period of time which you have extra storage that you don't actually need. Because the granularity is quite big, you are paying in advance for something you not actually use. And this is why in standard clustering in Scylla Cloud, we use 70% storage to trigger the next scale. Because scaling takes a lot of time, we have to start it pretty early, only on 70% storage. What we want to get to is to 90% storage with xCloud, and tablets and mixed instances cluster allow us to do that. And it's very straightforward when you see it a graph like that. What xCloud actually gives us is much more granular scaling. So we don't have to add the huge node in advance. We can add a very small node. If require another small node, then merge them to a bigger node, etc., etc. So the extra storage and compute that you are paying for is very small at all time. This is how we can get to a 90% storage utilization on xCloud. And this is a big change from 70% to 90%. If you calculate the cost of this storage, the cost of this compute throughout a year, for example, you will find out it's a significant way to save cost. So this is how it looked like. We started with the i4 16 extra large, but the first scale can be only with 2 extra large. Maybe you'll stop there. You don't need more storage. If you do need, xCloud will automatically scale for you with another instance, then maybe replace it with a bigger instance, etc., etc. By the way, I'm using i4i in all of my example, but as I mentioned now, there is i7i as well, which is even a stronger machine. So if you are starting to use a Scylla xCloud tomorrow, you might use the new instance already. Okay, and again, demonstrating the granularity difference between this graph show a similar picture, but with scaling in again. If previously you have to scale out and scale in with big units, you can do it in a more granular way and save both compute and storage usage. Okay, and for those of you familiar with this graph, please say so in the comments. To summarize the xCloud part so far, so as I mentioned, xCloud used the latest and greatest tablet feature from ScyllaDB to scale out faster, to scale in faster, and to support mixed instance size cluster, and all of that help you to save cost in 2 ways. One, you get 90% storage utilization instead of 70%. The second is that the scale out and scale in are just in time and very fast. So you don't have to scale a week in advance. You can actually let the cluster scale for you just in time. And with that, I want to switch to Michael to talk about a complementary feature on ScyllaCloud called flexible pricing.
Thanks, Zach. So we focused on making pricing more flexible and transparent to ensure that our customers have the right options to match their workload and budget needs. So to support different usage patterns, we structured our pricing plans and payment options to provide flexibility while keeping cost efficiency in mind. So ScyllaDB Cloud offers 3 different price plans. Each one is designed to support different types of workloads. The standard plan, which is ideal for production workloads that require a fully managed database, but without additional complexity. We have the professional plan, which is designed for mission-critical workloads, letting you bring your own account, for example, and a dedicated Slack access for faster issue resolution. And lastly, premium plan, which provides the highest level of security and flexibility, including advanced support and the ability to make dynamic deployment changes anytime. So beyond plan selection, we also offer flexible payment options, so customers can choose the model that best suits their budget or commitment level. So on demand is a pay-as-you-go model with no long-term commitment. It offers the most flexibility, but comes at the highest cost per unit. Flex credits, on the other hand, customers can prepay for usage of any cluster type at a discounted rate, providing a balance between flexibility and cost saving. And credits can be applied to compute, network, and backup usage, which makes them a great option for organizations with dynamic workloads. And lastly, reserved, which is the most effective option, where customers commit to a full year for a given instance type, securing the lowest possible rates. So by offering multiple plans and payment models, we aim to provide customers with the flexibility to scale their workloads efficiently while managing costs in an effective way. So Now that we've covered the different pricing plans and payment options, let's take a closer look at how you can optimize costs based on your workload patterns. So the first option is reserved capacity, which offers the most cost-effective pricing across all of our plans. And with this option, customers can commit to a set amount of cluster nodes or machines for an annual term. And this guarantees capacity availability while significantly reducing costs compared to on-demand pricing. And reserve capacity is ideal for workloads with steady and predictable usage. So if your cluster size remains relatively stable over time, it allows you to optimize spending without worrying too much about fluctuating costs. And next, we have a hybrid model, which is reserved plus on-demand. So with this approach, you commit to a baseline level of reserved capacity to ensure that you lock in lower rates for a portion of your workloads. However, if your usage exceeds that baseline due to, for example, a sudden traffic spike or unexpected demand, you can seamlessly scale up using on-demand capacity, which will be billed at an hourly rate. And this model is useful for businesses that have relatively stable usage, but do need the ability to handle unpredictable peaks without overcommitting to a fixed capacity. So it provides the security of reserve pricing while maintaining the flexibility to scale on demand when necessary. And lastly, another hybrid model we offer is reserved plus flex credits, which provides a more cost-efficient way to handle seasonal or event-driven spikes, for example. And with this model, you still commit to a baseline reserved capacity at the lowest possible cost, but instead of relying on on-demand pricing for peak usage, you can pre-purchase flex credits at a discount, which applies specifically to compute usage. Now, flex credits can also be used for network and backup usage, but those costs will remain at the standard cloud provider rates. So this model is ideal for companies with predictable peak periods, allowing them to optimize spending while maintaining flexibility. So by choosing the right mix of these payment options, you can optimize both cost and scalability for your workloads. So how do I make sure I'm on the cheapest tier and the cheapest payment model for every hour of the day? Well, that's where tablets comes in. So historically, you had to size a cluster for this blue peak line that you see on the graph, 3 times the everyday orange baseline. So you pay that bill 24/7, even if you only maxed out 4 hours a day. Now with tablets, ownership metadata lives in the file itself, so we can add or remove nodes in just minutes instead of hours of days. So practically, that means you can save a lot of money by pre-purchasing cheap flex credits or even on demand, for example, while your steady baseline sits on low rate reserved hours. And here's a production trace from one of our customers that puts numbers behind the promise. So the shaded bands you see on this graph show when the cluster was in peak mode. We then scaled up in 15 minutes. We handled the surge and then scaled back down in 18 minutes. So essentially what that means for pricing, around 80% resource reduction. So the baseline nodes stay on reserve pricing and the short spikes tap into flex credits. It also means lower subscription costs because tablets move fast. You don't need a bigger plan just to cover peak usage. And you can scale whenever needed, very easily and very quickly. Now, as part of our ongoing improvements to billing and cost management, we are going to introduce self-service contracts management, giving our customers full control over how their contracts are applied to their clusters. So with this feature, you will be able to view and manage all of your contract line items directly inside the platform, ensuring full transparency into your contract details and usage. But more importantly, you will be able to assign contracts to new clusters when scaling existing clusters, or to reassign them at any time to optimize cost efficiency. And this flexibility allows you to ensure that your contract terms align with your actual workload needs. And so the two key benefits of this feature are, for the first, transparency. You will get complete visibility into contract details and how they are applied. And secondly, flexibility. You can move contracts between clusters. So this means that As your infrastructure scales or shifts, you can always make sure that your contracts are being used in the most effective way possible. And here's a quick look at what's coming in the UI for self-service contracts management. So this interface gives you control over which billing option you want to apply to every cluster, whether at creation, during a resize, or at any point in time. So you can see existing contracts, you can assign them to specific clusters, or you can opt for on-demand pricing if needed. And this ensures that you're always applying the most cost-efficient billing method for your workload. And with this level of control, customers can make real-time adjustments based on their evolving infrastructure needs. So we're going to zoom in on the single biggest line item, which our cloud customers mainly complain about, which is network costs. And every gigabyte that leaves a node or crosses an AZ boundary or writes, for example, the backbone to another region, shows up on your AWS, GCP, or Azure bill. And so the next slides show the engineering work that we've done in ScyllaDB at different layers to shrink those bytes and the dollars that are tied to them. So first, let's start with data movement and tablets. As part of the tablets technology, we basically rewrote streaming around the new tablet abstraction. So think of it as Cassandra's zero-copy streaming, only that we actually keep ownership metadata with the replica. So we never read, reserialize, or retransmit rows. We just copy SS table files straight to the target node. What this means for you is up to 25 times faster streaming compared to previous Scylla versions. The next reduction is around compression. We shipped dictionary-trained ZSTD, which is pipeline aware. So what this means is that first, you can see on the graph, LZ4, which is the default in Cassandra, leaves you with 72% of the original size. Next, you have generic ZSTD, which cuts that to 50%, already an improvement. And lastly, our per cluster ZSTD dictionary basically takes it down to a further 30%, which is 3 times improvement, a better compression. So when you need multi-AZ or multi-region high availability, we can also keep costs predictable. Active shards replicate intelligently. Our placement service is latency aware, so it prefers intra-AZ traffic first. And combined with compression and tablet streaming, even cross-region repairs stay lean. And of course, not every workload needs 3 different AZs. If you're optimizing purely for cost and single-digit millisecond latency, a single zone cluster still gets full shard level replication inside the AZ. So you can avoid the inter-AZ premium cost entirely, this way of having a single zone deployment versus multi-zone deployment.
Thanks, Michael. So just to summarize what we've seen. So in the first part, I introduced Scylla and talk about performance improvement in the Scylla database itself and how it helps you to reduce cost. In the second part, we introduce xCloud, a new deployment type in Scylla Cloud that use tablet and allow you to reduce cost. And in the last part, Michael presented Flex Credit, which is a complementary feature that take advantage of the fast scale and allow you to pay only for what you need. In addition, Michael covered more cost reduction feature like compression and more. And with that, we want to thank you very much. And let me answer a few of the questions that accumulated in the chat in the meantime. Okay, so the first question, when can we use xCloud? And when can we use tablet? Okay, so tablet is actually available for quite some time. And if you download the latest release, 2025.1, you can use tablet already. Actually, tablet is the default. On the cloud, tablet is also available, in 2025.1, but if you want to use xCloud, it will be introduced in the next few days, or was already introduced if that's a recording that you are hearing. So check it out. We'll introduce xCloud in phases, beta first, and very soon we'll move to production. And I hope that's answered the question. Second question, maybe for Michael, is Flex Credit something that Scylla user can use or Scylla Cloud user can use right now?
So great question. So Flex credits can actually already be purchased today as part of our Pro or Premium plans. And it will be available very soon in Scylla Cloud via self-service.
Thanks. And I see a related question, maybe to the first one, is tablet and vNode compatible? And I can reword it in a different way. Is xCloud cluster and a standard cluster compatible? And the answer is not completely. So that's a good question. xCloud, which have a support for tablet and the fast scale out and scale in, does not support all the features right now. In particular, it doesn't support yet material view and secondary index. We are working to close this gap, and very soon, probably in the next Scylla minor release, tablet and xCloud will be compatible. But we do allow you to start a standard cluster on Scylla Cloud if you want to use some of this feature. And if you don't need them, we recommend going with the default and xCloud. I hope it answered the question. Oh, okay, I see another question regarding the latency comment. Yes, so regarding the latency, I mentioned a conference, the conference called P99. We can add in the chat a link to it. And it's a very deep tech engineering conference just about improving latency and performance in software system, not just about ScyllaDB, all kind of system. Usually there are presenters from all around the domain. Okay, and that's it. We will stay on the chat to answer more questions. You can also join the Slack or the forum, and Michael and I will answer questions there, and other people can answer questions throughout the day and night. So thank you very much.